Okay, here's where we left off in the last video. Let's continue on to that last page of your notes, introducing some more vocabulary and drawing some more pictures. Starting off with this vocabulary term called coherent, describing waves with the same frequency that are in phase with each other. In phase just means that as the waves travel, everything lines up. All the crests of the waves line up with crests, all the troughs line up with the troughs, and this is a little bit tough to achieve with multiple sources of the wave. They have to be very careful to start them at exactly the right time, and they have to match in all ways. And so the easiest way to make coherent waves is to have a single source. So let's go back to the idea of water waves. Let's imagine that you're near a pond, and you see the water is all nice and calm, and then you drop a rock into the pond. So that's what the picture is shown on your page there. So imagine you're following the rock, it falls here and hits the water. This would be the surface of the water. And of course what's going to happen, it's going to make ripples. It's going to make waves. So if you were to draw one of those waves from the side, you would see it as the crests and troughs, this transverse wave, as it's traveling to the right. But this is only if you're looking dead on from the surface of the water. You're looking, down at the water, you're going to see a whole bunch of these waves. So let's add some more pictures of this. And this is what you're going to draw right there on your notes page. Add some more of these transverse waves going in sort of all directions. We're going for sort of a curvy sine curve picture here. And try to fill in some of those gaps like this. And hopefully now we see almost what looks like a three-dimensional picture of the crests and troughs as they spread out. You can almost see, like, these are the crests, and these are the troughs, and the crests, and the troughs, and the crests, and troughs. Now, this picture is a little bit tough to visualize, plus it's not really where you're going to see. Where you're really going to see are the ripples on the pond, and really, that's sort of like the shadows of the crests or the troughs. That's what you would see. These blue lines here are sort of these imaginary lines connecting crests or troughs. And we give a name to this. This is called the wavefront. This imaginary line connecting crests or troughs. These are the ripples in water waves. We also want to show which way the waves are moving. And so if here's the source, the waves are going in all directions outwards from the source. So we can draw some arrows showing this motion. These arrows are called rays. An arrow showing the direction the wave travels. And by definition, the rays are always perpendicular to wavefronts. And so while this picture we've drawn here is actually quite complicated, it provides a way of simplifying the picture. If we sort of tilt this picture and look at it from above, you wouldn't see all those crests and troughs, you just see the ripples. And so it looks something like this. If you're looking directly down, so here's where the rock hits the water, you'd see these circular ripples all spreading out. I was trying to draw all these circles being concentric, which is actually tougher than I thought it would be on PowerPoint, but there they are, trying to make them as concentric as possible, in circular in shape. So those are the ripples on the surface of the water. If we were to add the rays to the picture, well, if this is the source of the waves, the rock hits the water, these rays would show the waves are going in all directions outwards. This is what we call circular wavefronts. Makes sense, right? This also shows this idea here, the rays are always perpendicular to the wavefronts. By definition, since these rays are the radii of circles, radii always cross over the surface of the circle at right angles. So these rays are always perpendicular to the wavefronts. Now these ripples expand outwards, making larger and larger circles. As you get larger and larger, the shape of the circle kind of flattens out to the point that if you're very, very far away, these look like they're perfectly straight. If you were to add the rays to the picture, it would be like this. Really, these are rays that are emanating from here that are very, very slight angles to each other to the point that if you're very far away, these rays look like they're parallel to each other, and the wavefronts look like they're parallel to each other. Now we have what are called plane wavefronts, meaning they basically form like a geometric plane. So this way of viewing waves is just a little bit easier rather than constantly trying to draw all these crests and troughs, which is actually very complicated, especially if things propagate outwards in 2 or possibly even 3 dimensions. That would become nearly impossible. But showing these wave fronts and the rays associated with them makes our job much easier. We're going to use this a lot when we draw pictures of waves and show the properties of waves, this idea of the wave fronts and the rays. And so after being exposed to all these vocabulary and drawing all these pictures, you're now well set up to see all the great demonstrations we're going to do in class next time.